Good morning. My name is Ferhan Mazher, and today is 6th of November 2020. The day is Friday. Right now, I am with the 10 Cambridge class, and the subject we are studying is Physics 5054. Today's task is to do a worksheet on MCQs worksheet on the topic of general wave properties. And we are done with the chapter of waves in our class. Most of the chapter is done. Only I think one or two lectures are required. So let's do this worksheet, and it will make your concept more clear. For a transverse wave, what is a wavefront? Wavefront is an imaginary line that joins all the adjacent points in a wave which are in the same phase. A line joining all the points on the same crest of a wave. That is the right answer. So A is the right answer. A is the right answer. Okay. A longitudinal wave passes along a spring. The coils of the spring vibrate from side to side. The diagram shows the positions of the coils at one particular time. Which positions are one wavelength apart? Okay. So one wavelength will be from the center of a crust to the consecutive center of the crust. W and Y is one wavelength, and Y and Z can be the one wavelength. W and Y, that's not given there. Y and Z is given from one center of the compression to the consecutive center of the compression. That will be the one wavelength. So this is the one wavelength, YZ. This is also one wavelength, WY. But in the options, only YZ is mentioned. So D is the choice. So the right choice will be D. I hope you have understood. A water wave in a ripple tank refracts as it passes from deep water to the shallow water. Which properties change as the wave refracts? I have told you many times that the wavelength will decrease. It will change. The speed will decrease. It will change. The frequency will remain unchanged. So the choice is speed and the wavelength. So the right choice is D, speed and wavelength. They will change. Which properties change as the wave refracts? Speed and wavelength. Frequency remains unchanged. So D is the choice. Next is question number. This is question number 4 on your screen. The sound waves travel through air. The sound waves are longitudinal waves. The lines in the diagram shows the positions of layers of air at one particular time. Which distance shows the wavelength of the wave? It should be okay. From the center of the compression to the center of the next compression. That's one wavelength. So D is the choice. Which distance shows the wavelength of a wave? It's from the center of one compression to the center of the next compression. So D is the exact choice. D represents one wavelength. So for question number 4, D is the choice. A wave in a ripple tank passes from a deeper to a shallower region and refracts. Which wave properties decrease as the wave enters the shallow region? The wavelength will decrease, the speed will decrease, the frequency will be unchanged. So speed and wavelength. So D is the option. When the water waves enter from deep water to a shallow water, the wavelength decreases, the speed decreases, the frequency remains unchanged. So D is the choice. Next question on your screen, question number 6. A ball floating in a ripple tank begins to move vertically up and down as a wave passes beneath it. The ball does not move horizontally. Which statement is correct? Both energy and water are transferred in the wave direction? No. Only the energy is transferred in the direction of the wave. Energy is not transferred. That's wrong. Energy is transferred in the wave direction, but water is not. That's right. C can be the answer. Neither energy nor water is transferred. That is wrong. So C is the right answer. C is the right answer. So the next question on your screen. In an experiment using a ripple tank, plane wavefronts arrive at a plane surface, which row correctly describe the waves after they are reflected. After they are reflected from the surface. Speed of the waves that do not change, wavelength do not change. When the reflection of the water waves happen, the speed do not change, the wavelength do not change, the frequency do not change, only the direction of the water waves changes when the reflection of the water waves take place. So the speed of the waves the same and the wavelength same. This is we are talking about we are talking about reflection. We are not talking about refraction. Question number 8. Which statement is correct? Infrared radiation cannot travel in a vacuum. That's wrong. Infrared radiation cannot travel in solids or in gases. That is also wrong. Infrared radiation can only travel in a vacuum, and infrared radiation can travel in a vacuum and in gases. So D is the best option. That's the correct option, sir. D. Question number 8. D is the right option. Water waves refract at a boundary between deep water and a shallow water. What is the effect on the frequency, wavelength, and speed of the waves at the boundary? The frequency will be unchanged. The wavelength will decrease. It will change. I mean, the speed will decrease. I mean, it will change. The wavelength and speed will change, but the frequency will remain the same. So C is the choice. Question number 9, C is the right choice. What is the frequency of a wave? It is the number of waves passing from a point in unit time, or in 1 second, or per second, you can say. So the number of waves passing a fixed point per second, that is the answer. So for question number 10, A is the right answer. For question number 10, A is the right answer. Which statement is correct for all electromagnetic waves? All the electromagnetic waves are transverse wave. Remember, don't forget this fact. It's a fact that all electromagnetic waves are transverse waves. Don't forget this fact. So question number 11, A is the choice. A wave of frequency 13,000 hertz travels 1300 meter in 4 seconds. What is the wavelength of the wave? Okay, so we can quickly solve this. Let me here. Make it here. So it traveled 1300 meter in 4 seconds. So from here, I can find out the velocity. Velocity is equal to the distance traveled divided by time. So it is 1300 divided by 4 seconds. And the answer will be, let me do it on the calculator. So it's 1300 divided by 4. So the velocity is 325. And you know V is equals to F lambda. V is equals to F lambda. So lambda will be equals to, so the wavelength, which represents lambda. The wavelength is equals to V divided by velocity divided by frequency. So the velocity is 325 divided by the frequency. The frequency is 13,000. So let's see what's the answer on the calculator. I will do this calculation. 325 divided by 13,000. So its frequency is 0.025 hertz. 0.02, sorry, the wavelength is 0.025 meter. So A is the choice. A is the right choice. I hope you have understood this. First, I calculated the velocity, distance divided by time. Then I applied using the wave equation. V is equals to F lambda. So if I want to find out lambda, that will be wavelength is equals to velocity divided by frequency. Simple calculation. A is the choice. A star explodes in outer space. Which waves from the exploding star do not reach the Earth? Infrared, they can reach the Earth because they are electromagnetic waves. They can travel in the vacuum. Light, that will reach because they are electromagnetic waves. They can travel through the vacuum. Radio waves are electromagnetic waves. They can travel through the vacuum, so they will reach. Sound is travels by longitudinal wave, but they cannot travel through the space, the vacuum. So the sound waves will not be able to reach the Earth. So question number 13, D is the answer. Sound waves will not be able to reach the Earth because the sound waves are longitudinal waves. They are mechanical waves. They require medium to travel. They cannot reach the Earth. They cannot travel in the vacuum. 13, D is the choice. A ripple tank is used to show a wave behavior. The dipper vibrates up and down at a constant frequency. What happens to the frequency and to the speed of the waves as it reaches the glass block? So here the water above the glass block is shallow. So when the water waves will reach in the shallow waters, their wavelength will decrease, their speed will decrease, but the frequency will remain the same. Frequency remains the same and the speed will decrease. So C is the choice. So C is the choice. Okay. Question 15. A wave has a frequency of 10 kilohertz. Which pair of values of its speed and wavelength is possible? So here the speed and the wavelength is given 10 kilohertz. 10,000 hertz, 10 kilohertz is the frequency. From this speed and wavelength, we can do the calculation and check whose frequency is 10,000. So let me do the calculation for you. Okay. So the frequency is equals to velocity, that's 330, divided by the wavelength, that's 0.33. Let's check what's the answer. 330 divided by 0.33, and the answer is 1000. So it's not the option. Okay. So for B option, let's check what's the answer. The speed is 330 and divided by the wavelength is 33. So let's see what's the answer. 330 divided by 33 and the answer is 10. So that's not the right option. The third option, F is equals to speed divided by the wavelength. So it will be 3 point. Let me do this on the calculator. I will 3 on your calculator. You can write 3 expo 8 divided 30, and the answer is it's 1, 2. Its answer is 1 and 1, 2, 3, 4, 5, 6, 7. 7 zeros. 1, 2, 3, 4, 5, 6, 7. This is the answer I got. Okay. So 3 and 3 and 1. Yes. The next D option. the frequency will be speed, that's 3 divided by the wavelength. Let me do the calculation. You can do also the calculation with your scientific calculator. On your calculator, you will write speed, which is 3 expo 8 divided by 3 expo 4. And the answer is this. There are 4 zeros. 1, 2, 3, 4. So this is basically equals to 10,000. 10 kilohertz. So D is the choice. I hope you have understood this. So D is the right choice. Question number 15, D is the right choice. I hope it's clear to you. Energy can be transferred in many different ways. In which situation is energy transferred by wave motion? Colliding atoms in a heated copper rod? No, that's not by wave motion. Fast moving electrons in a cathode ray oscilloscope? This is not the wave motion. Hot water rising in a heated saucepan? That's not the wave motion. Ripples passing across water in a ripple tank? That's the example of wave motion. So D is the choice. So for question 16, D is the right choice. Which of the following travel as a longitudinal wave? A radio wave in air? Radio waves are transverse wave. A sound wave in a solid? That's a longitudinal wave. A wave on a rope shaken from side to side? That's a transverse wave. An infrared wave in the space? That's also a transverse wave. So longitudinal wave, B is the choice. Question 17, B is the right choice. The diagram shows a ball floating in a tank of water. Which diagram shows the movement of the ball as the wave passes? The waves are going from left to right. And because in water we have transverse wave, the particles of the medium will vibrate perpendicular to the direction of the wave. So the ball will vibrate up and down. So D is the right choice. D is the right choice. A wave has a frequency of 2 hertz. How many waves are produced in 1 minute? How many waves are produced in 1 minute? You know, the frequency means the number of waves produced in 1 second. So there are 2 waves produced. The frequency is 2 hertz. So it means there are 2 waves produced in 1 second. In 1 minute, we have 60 seconds. In 1 second, 2 waves are produced. So in 60 seconds, how many waves will be produced? 2 multiply 60. So A is the right choice. A is the right choice. The diagram shows the pattern of waves in a ripple tank. What does this pattern shows? The wave fronts came, collided with that barrier, and the direction of the wave fronts have changed. The distance between the wave fronts before colliding and after colliding has not changed. So it means it's reflection. It's the reflection of waves. So A is the choice, the waves being reflected from that barrier. From this barrier, the wave fronts have been reflected. The wave is reflected. A is the choice. In a ripple tank, a vibrator produces circular wave fronts which hit a flat surface. The reflected wave fronts are also part of the circle. Where is the center of these circles? You see, here the process of reflection is taking place. The water wave is reflected. So it's exactly like the reflection in a mirror. If you see, here is the actual center of from where the wave fronts are being produced, and from this barrier, the waves will be reflected. The distance of the actual source from or the vibrator is this. So its image will be exactly that much distance behind this barrier. So A looks the best option. These are water waves being reflected from a flat barrier, and the center or the vibrator position behind the they will appear to be coming from there. They are not actually coming from there, but it will appear that the center of the reflected wavefronts is behind the barrier, and it will be exactly like the image in a mirror. So if the actual vibrator is this much in front of the barrier, its image will be the same distance behind the barrier. So A is the choice. It's a little tricky question. It's like reflection in the mirror, but it is actually the reflection of the water waves in a barrier. Very important question. The displacement distance and displacement time graphs are for a water wave in a ripple tank. What is the speed of the water wave? So from these two graphs, it's a displacement distance graph. So from here, I can guess what is the wavelength. The wavelength is 2 centimeters. From this graph, I can find out the time period. From this displacement time graph, I can find the time period. The time period is 0.04 seconds. So once I know the time period, I can let me do the calculation here. So let me show you. Okay. So I know the time period. The time period is equals to 0.04 seconds. Okay. So I can find out the frequency. You know, the frequency is equals to 1 divided by time period. So it will be 1 divided by 0.04, and the answer will be, let me do this calculation, 1 divided by 0.04, and the frequency is 25 hertz. So now I know the frequency, I know the wavelength. So the V is equals to, you know, F lambda, wave equation, V is equals to F lambda. So F is 25 and the lambda is 2 centimeters. So my answer will be 50 centimeter per second. So it will be 50 centimeter per second. So the answer is D. It's very important question. Very, very important question. We used the displacement distance graph to find out the wavelength. We used the displacement time graph to find out the time period. And then I calculated the frequency. Then I applied the formula V is equals to F lambda. And from calculation, I came to know that the speed of the wave will be 50 centimeter per second. Okay. Next question on your screen is a student uses a spring to demonstrate wave. He moves the spring with his hand. Spring placed on earth. Which diagram demonstrates the type of waves produced by a source of sound? The source of sound produces longitudinal waves. And in the spring, you can produce the longitudinal wave, and the spring should show compressions and rarefactions. So which diagram is showing the compressions and rarefactions? That's B. So B is the right option. B option is showing the sound waves type wave, longitudinal wave. So B is the right option. Which diagram shows an example of a longitudinal wave? Light traveling from a lamp to a screen. Light is transverse wave. A spring pushed backward and forward. Yes, that shows longitudinal wave. It has compressions and rarefaction. So B is the best option. C, a spring pushed up and down. That's a transverse wave. A water ripple and that's also a transverse wave. So B is the right option. Which diagram correctly represents water waves traveling from deep water to shallow water? Deep water to shallow water. You see, when the water waves will move from the deep water into shallow water, the wavelength should decrease. The wavefronts should come close to each other. The wavelength should decrease. So B and the D, they both are wrong because the wavelength has increased. The wavefronts have moved away from each other. So B and D cannot be the option. The second point is when the water waves move from deep water to shallow waters, they bend towards normal. They will bend towards normal. So in the C option, you see, if I draw a normal here, and you can see if I draw a normal here, this has bended away from the normal. So C is wrong. If I draw normal here, you can see it has bended towards normal. The wavefronts have come closer in the shallow water. So A is the right choice. When the water waves move from deep water into shallow water, the wavefronts should come close to each other. The wavelength should decrease. Plus, the direction of the wavefront should move towards the normal. So A is the right option. Very important question. Okay, on your screen, the diagram shows different views of a water wave in a ripple tank. Which latter represents a wavelength and a wavefront? So these lines, they represent wavefront. So R is representing the wavefront, S is representing the wavelength, P is also representing the wavelength. So P is representing the wavelength and the R is representing the wavefront. So A is the choice. A is the right choice. This Q is basically representing the amplitude. So A is the right option, sir. Here we have a ripple tank used to demonstrate refraction of plain water waves. So here, deep water, here shallow water, refraction of the water waves has taken place. Here the wavelength is 1.2 centimeter, the speed is 9.6 centimeter per second. Here in the shallow water, the wavelength is 0.8 centimeter. Waves in deep water have a wavelength of 1.2 centimeter and a speed of 9.6 centimeter per second. The wavelength of the waves in shallow water is 0.8 centimeter. What is the speed of the waves in the shallow water? It's a very famous and tricky question. Let me show you. So we will do the calculation in this portion. Here in the, here. You see in the deep. So first of all, I'm going to do the calculation in the deep water. For the deep water, you see, okay. So the velocity is given, the wavelength is given, so I can find the frequency, and you know the frequency is equals to speed divided by the wavelength. So the speed is 9.6 and the wavelength is 1.2. So let's see what's the answer. 9.6 divided by 1.2. So the frequency is 8 hertz. The frequency is 8 hertz. And we know that when the water wave will enter into the shallow water, so in the shallow water, the frequency will remain unchanged. So then the shallow water, the frequency will be also 8 hertz. And the wavelength in the shallow water is 0.8. So I can calculate the velocity. V is equals to F lambda. F will be 8 and the lambda will be 0.8. So when you multiply them, let me check. So 8 multiply 0.8. And the answer will be 6.4 centimeter per second. 6.4 centimeter per second. So the choice is A. The right choice is A. I hope you have understood. It's a very good question. Okay, so on your screen we have question number 28. When ice melts to become water, which force must be overcome? When ice melts to become water, which force must be overcome? We have to overcome the force of attraction between the atoms or between the molecules. Intermolecular force needs to be overcome. The attraction between electrons and nucleus, no. The attraction between the atoms in a molecule, no. The force between the molecule, yes. Intermolecular force. The force of gravity, no. So C is the right choice. Question number 28, C is the right choice. Which factors increase the rate of evaporation of a liquid? Rate of evaporation of a liquid. Increasing its temperature, yes. Increasing its surface area, yes. Increasing its depth, it has no effect. So B is the right choice. Question number 29, B is the right choice. This is not a question on the topic of wave. Unfortunately, it is there. It is there. I don't know why. The diagram shows a water wave in a ripple tank. So let me show you. Okay. The wave has a speed of 12 centimeter per second at R, where the water is deep, and the wave crosses the boundary PQ, where the distance between the crust changes from 3 centimeter to 1.5 centimeter. The wavelength has changed. What is the speed of the wave at S? Okay, very simple. We have already done a question like this in a previous question. We do that. Let me bring it here. Okay. So at the position R. So at deep water, in the deep water, you know, V is equals to F lambda. I know the speed, so I can calculate the frequency. Frequency will be equals to V divided by wavelength. Velocity is 12 and the wavelength is 3 centimeter, and the answer will be 4 hertz. Now the water wave entered into the shallow water. In the shallow water, the one thing which will not change is the frequency. I know the wavelength. The wavelength in the shallow water is 1.5 centimeter. So by applying the wave equation, V is equals to F lambda. So V equals to frequency, that is still 4 hertz. The frequency do not change. And multiply the lambda. The lambda here is 1.5. So when you multiply 4 with 1.5, the answer will be 6 centimeter per second. So the right choice will be B. B will be the right choice. 6 centimeter per second. I hope you have understood this. The diagram shows refraction of water waves as they cross a boundary in a ripple tank. What causes this refraction? A change in the frequency due to a change in the depth? No. The frequency do not change. A change in the frequency due to a change in the wavelength? That's wrong. Frequency do not change. A change in speed due to change in depth? That can be right. A change in speed due to change in the frequency. I told you the frequency has not changed. So the speed, the wavelength has decreased, the speed has decreased, frequency has not changed, and this happened due to the depth. So C is the best option. A change in speed due to change in depth. So C is the right option. C is the right option, sir. Again, a numerical. Okay. This is question number 32, numerical. Here, the speed in the deep water is 2 meters per second. The wavelength in the deep water is 1 meter. The wavelength in the shallow water is 0.4 meter. What is the speed of the waves in the shallow water? You see, the procedure is very simple. Let me open the text box. Oh. So we are in the deep water. In the deep water, what happens? See, V is equals to F lambda. So F will be equals to F is equals to velocity divided by the wavelength. So 2 divided by 1, and the answer will be 2 hertz. So when the water wave will reach the shallow water, the frequency will not change. So the velocity V is equals to F lambda. F is still 2 hertz, and multiply with the wavelength, that's 0.4. When you will multiply these two, the answer will be 0.8 meter per second. 0.8 meter per second will be the velocity. I hope you have understood. Okay. What is meant by the term wavefront? Wavefront is an imaginary line joining all the adjacent points in a wave which are in phase. So it's a line joining points along the peak of a wave. That can be true. A line joining the trough and the peak, that can be wrong. So C is the best option, sir. It's an imaginary line which joins all the points which are in phase and are adjacent to each other in a wave. Like all the points on the peak, you can join them with an imaginary line. That will be the wave front. Question number 33, C is the right option. The diagram shows how displacement varies with time as a wave passes a fixed point. So it's a displacement time graph. From displacement time graph, I can easily tell you the time period. From the graph, I can tell you the time period. So from this graph, you can see here a wave is completed. So the time period is 2 seconds. The question is, what is the frequency of this wave? The frequency is equals to 1 by time period, reciprocal of the time period. So 1 divided by 2. So I will do 1 divided by 2, and the answer will be 0.5 hertz. 0.5 hertz. So B is the right option. I hope you have understood. The frequency will be 0.50 hertz. You see, the study is very simple. From the displacement time graph, I just noted down what is the time period of this wave. Then the frequency is 1 by t. F is equal to 1 by t. I just did the calculation. The answer is B, 0.50 hertz. The diagram shows part of a spring that is shaken from side to side to produce a wave. The distance between successive peaks is 0.60 meter and the frequency is 2.5 hertz. How long does it take for a wave to travel 3 meters along the spring? So you know the wavelength is given 0.60 meter, and the frequency is also given 2.5 hertz. So I can find the velocity. V is equals to F lambda. Velocity is equals to frequency 2.5 multiply lambda. That is 0.60. So when I multiply them, I get the velocity, that is 1.5 meter per second. So the velocity is 1.5 meter per second. Now the distance needed to be traveled is 3 meters. I want to know the time, how much time it will take. So I know the speed, that's 1.5 meter per second. The distance to be traveled is 3 meters. So time is equal to distance divided by time. So 3 divided by 1.5. 3 divided by 1.5 and the answer will be 2 seconds. So C is the choice. I hope you have understood. First, the wavelength was given and the frequency was given. I calculated the speed of the wave, V is equals to F lambda. Then the distance to be traveled is given and the speed I just calculated, and I need to know how much time it will take. Time is equal to distance divided by speed. So we did the calculation, the final answer is 2 seconds. So C is the right choice. The diagram shows a wave on a string with 2 points P and Q marked. The wave is moving in the direction shown. What will happen next? I told you in a lecture that see what will happen with the Q. That is what is happening with the wave behind on the left side of this. If the wave is going in this direction, if the wave is going towards the right, so what will happen with the Q? Whatever is on the left side. So the Q will move upward. What will happen with the P? Whatever is on the left side of the P. So the P will go downward. So what will happen next? The P will move to the right. No, the P will move up. That's wrong. Q will not move. That's wrong. Q will move up. That's right. It's a tricky concept. If the wave is going from towards right, so what will happen with the particle of the medium? Whatever is on the left side of that medium, that will happen. So Q will move up. So D is the right choice. The dipper in a ripple tank vibrates at a frequency of 4 Hertz. The frequency is 4 Hertz. And the resulting wave pattern is photographed. The distance between the two crusts shown is 20 centimeter. So this distance between these two crusts is 20 centimeter. So how many wavelengths are there? 1, 2, 3, 4, 5. So there are 5 wavelengths. And that's 20 centimeters. So one wavelength will be 20 divided by 5. So one wavelength will be 4 centimeter. One wavelength will be 4 centimeter. The frequency also 4 Hertz. So we can calculate the velocity V equals to F lambda. V equals to F lambda. F is 4 and the lambda is 4 centimeter. So multiply 4 with the 4. So this will be 16 centimeter per second. So C is the choice. C is the choice. 16 centimeter per second. The diagram shows a wave moving into shallower water. Okay. The wavelength of the waves is reduced because both the frequency and the speed decreases. No, frequency do not change. Both the frequency and the speed increases. No, frequency do not change. Only the frequency increases. No, that's wrong. Frequency do not change. Only the speed decreases. Yes, D is the choice. D is the right choice. Only the speed decreases. The wavelength decreases, the speed decreases. Frequency remains unchanged. Where we have question number 39. The diagram shows a graph of wave motion. It's a displacement time graph. Which quantities are shown by the distance P? P is telling you the amplitude. And this Q is representing the time period. So A is the choice. Question number 39, A is the right choice. Which of the following is an example of a transverse and a longitudinal wave? Light is a very good example of the transverse wave, and the sound is a very good example of longitudinal waves. Radio is also a transverse wave. So B is the right choice. Transverse wave, radio waves are transverse, and the longitudinal waves are sound waves. Okay, so here we have another question, question number 41. He says the diagram shows a water wave in a ripple tank. The wave has a speed of 12 centimeters at r, and the wave crosses the boundary PQ where the distance between the crest changes from 3 centimeter to 1.5 centimeter. What is the velocity of the wave at the point S? Okay, so I know in the deep water, I know the velocity, I know the wavelength. So divide the velocity 12 with the wavelength, that's 3. You get the frequency, that's 4 hertz. The frequency in the deep water is 4 hertz. When the water waves enter into the shallow water, the frequency do not change. So the frequency in the shallow water will be still 4 hertz. The wavelength in the shallow water is 1.5. So I can calculate the velocity. So 4 multiply 1.5. So 6 centimeter per second. So B is the right option. B is the right option. I hope you have understood this numerical. The diagram shows the variation of the displacement of a wave with distance from the source. What is the amplitude? The amplitude is this distance from the mean position, or from the mean position how down you went. It's 2 centimeter. This is 2 centimeter. The amplitude is 2 centimeter. So that's it. So this was the so this was a worksheet on the general wave properties, and we are by the grace of God we are able to finish it, and I hope that it will increase, it will enhance your concept about the waves. This worksheet I have taken from a website, and the name of the website is savemyexam.co.uk. The name of the website from where I got this worksheet is savemyexam.co.uk. So everybody, thank you very much, and I hope that this video is helpful to make you understand the concepts of the wave. My name is Ferhan Mazher, and today I was with the 10 Cambridge class, and I hope that you have understood all the concepts. Thank you very much. Have a good day. God bless you all.